Welcome to our lesson on polynomials. Today we're going to look at three operations with polynomials: adding, subtracting, and multiplying. We've already looked at monomials, which are singular terms, so we're graduating to polynomials, which is basically a bunch of monomials that are adding or subtracting to each other. So poly means more than one. A term is basically just a monomial, and like terms are monomials that can be combined because they have the same variables with the same powers. Here is a polynomial expression made up of monomials, specifically made up of 1, 2, 3, 4, and 5 monomials. When you're comparing monomials in a polynomial expression, you're looking to see if there are any that are alike. So when you are looking at the variables, you're looking at the variables and powers, and then you're trying to match up if there are any that are identical. And in this case, this guy here is the same as that term right there because of the x squared y to the fourth matching exactly variables and powers. Here are two specific terms for two specific sizes of polynomials. We have the trinomial, tri prefix for three unlike terms, and the binomial for two unlike terms. Earlier we've done some simplifying with monomials, and this will be much like doing that. The process is very similar because since we're simplifying, we are continuing to use PEMDAS, or the orders of operations. Now we're just throwing in addition in the mix of things. So you're going to need to pay attention that you follow PEMDAS. So addition and subtraction have to follow the other parts already simplified prior if anything needs to be. When you're multiplying, you need to pay attention that that's when your powers on your variables will change, either the product rule or if you're dividing, the quotient rule. When you're adding and subtracting, your coefficients of your like terms do the adding and subtracting, but your powers don't change at all because powers will only change with the power rules that involve multiplying and dividing. So adding and subtracting will not change powers. Here's the first example that we'll look at where we have a trinomial getting subtracted from another trinomial. So here is a difference of two trinomials. There are really a couple ways you can go about completing this problem. Probably more than a couple ways, but I'll show you two specific ways to go about doing it. In the first method, the first thing I'm going to do is have you look at the subtraction here as a -1 value that you've got to multiply or distribute to the second group, since it's kind of basically what the negative sign is saying there. So in the first step, we're going to write the whole problem out again and distribute that subtraction as if it's a -1 multiplier. So multiplying to the x squared makes it negative, multiplying to the 4x makes that negative, multiplying to the -2 makes that positive. After that parentheses are gone and we've distributed that negative sign, then you can match up and combine like terms, such as the x squares go together, the x's go together, and then the regular numbers go together. So combining our like terms, 3 minus 1 is 2x squared. Notice the powers don't change because we're not multiplying. We're adding the coefficients in front of the variables. -2 minus 4 go together to make -6, and 3 plus 2 is 5 to make our last value there. The second method is to actually distribute the negative at the same time as pairing up the like terms. So here's what I mean by that. Starting left to right, 3x squared minus the x squared. So you're basically looking for the match, if there is one, immediately in writing those two together. So again, 3x squared minus x squared, and then back to the left, negative 2x minus negative or minus 4x. So then the last, going back to the 3, positive 3 minus a negative 2 means minus a negative is plus 2. And here then we've combined our like terms already. And that might make things easier for you to view the like terms rather than having to skim along the lines down there. So you can pick the method that works best for you. Here's a new example. We have a monomial multiplying to a polynomial. So the key is applying the distributive property to take the 2x, multiply it to the first mono, then multiply it to the second, then multiply it to the third. So here is a quick expansion of this here before writing the answer. 2x times 7x squared plus 2x times negative 3x plus 2x times positive 5. And then simplify each parts. 2 times 7 is 14. X times x squared is x to the third. There's that power rule, product rule. Plus 2 times negative 3 is negative 6. X times x is x squared. Plus 2 times 5 is 10, and you just got x. And I'm just going to fix this here. I don't like that plus negative. That's kind of old school. We're now in new school here with Algebra 2. And you always want to make sure you double check, have you combined all like terms? X cubed, x squared, x, those are 3 unlike terms, so they cannot be combined, and that is the answer. Here is a new type of problem, multiplying 2 binomials. A binomial, 2 terms, multiplied to another pair of terms. So the key here again is the distributive property once again. You're going to take your 3y, multiply it to the first value in the parentheses, then you're going to multiply it to the second value. The 3y is done. You have your 2. That's next. So your 2 is going to multiply to the first value there, and then it's going to multiply to the last value there. And at that point, everybody's had a turn to multiply. Every part of this group has had a chance to multiply to that group. You're going to combine like terms if there are any. Because of this scenario of a binomial times a binomial, we have a special name for the multiplication process of this, and it's called the FOIL method. FOIL is a mnemonic device to remember the process for multiplying. F for first, O for outer, I for inner, L for last, thus the mnemonic device FOIL. So F represents the first value multiplying together. That's this pair right there. The O for outer is referring to the outermost values. That would be the 3y in this group and the 4 in that group. So the outermost values in the whole problem. The I is the opposite. It's the innermost values. So the 2 central values would be this pair right here, this 2 and then this 5y, and that's what is represented by I for inner, and then last is referring to the last value here in this parenthesis with this last value there in that parenthesis. So it's just a special name given to the distribution process, And the reason that I like to use this name is because we're going to have to reverse this when we're doing factoring. And it's easier if you know your FOIL parts, your first, your outer, your inner, your last values, then it becomes easier to reverse this later when we have to actually find what are some missing values in the grouping. So again, in the expansion form here, you've got your first 3y times 5y, which gives you a 15y squared. You've got your outer values here, so plus 3y times positive 4 is 12y. Then you have your your inner values, plus 2 times 5y is a positive 10y, and then you have your last 2 times 4. Positive 2 times 4 is plus 8. And then once your multiplying is done, you're going to always have 4 parts, 4 monos. And then usually the ones that you'll see us do is we're going to have like terms to combine. They're usually the outer and the inners. So in the end, you have an answer that is a trinomial. So 15y squared plus 12 plus 10 is 22y plus 8. And that is the result of multiplying this binomial times binomial. Here's the last example we'll look at with multiplying polynomials. Here is a trinomial multiplying to a binomial. We don't have a special name for this process. It's just simply using the distribution process, trying to keep your work organized. So basically your n squared is going to multiply to the first value in the other group. Then it's going to multiply to the second value. Your 6n is going to multiply to this n, and then it's going to multiply to the 4. And then last but not least, you'll have your negative 2 multiplied to the n, your negative 2 multiply to the 4. So showing all my work here, I'll have n squared times n plus n squared times 4. I'll have 6n times your n. I'll have 6n times your 4, and I notice my signs are on purpose here because I know the signs in front of the values. Negative 2 times your n, negative 2 times 4, and then multiplying this using some power rules, n to the third plus 4n squared plus 6n squared plus 24n minus 2n minus 8. And now that the distribution has been applied, we want to, and we've simplified, now we're going to check for like terms. Are there any values that go together? So n cubed doesn't have a partner, but you've got an n squared here that can combine there. You've got some regular n's that can combine together. Negative 8 stands alone. So finally, as our end result here, we've got n cubed plus 10 n squared, 4 plus 6. Then our n's, we've got 24 minus 2, so that's 22n minus 8. And so that we're left with a polynomial with 4 terms.